Okay, we're starting with number 16 now on the Unit 1 review. Unit 1 review, section 6 through 8. This is our fourth video, starting at 16. All right, an empty swimming pool is shaped like a rectangular prism. Whoops. Oh my God, I don't know if I can do this. Let me do it like this. Okay, so maybe you have a swimming pool that looks like this. Okay, so you need like width, you need length, and you need height. Okay, just because you have a box like this, something made for a swimming pool, it doesn't have to go all the way to the top. Maybe the water is just going to fill this portion right here. Okay, as you're filling up, the pool rises. As time goes, the pool rises. Okay, so an empty swimming pool is shaped like a rectangular prism with a length of 18 feet. So we'll do it like that. Length of 18 right here. And has a width of 9. So we'll say that's this. And once the water begins to be pumped into the pool, so maybe the water's being pumped with a pump or maybe even a water hose, the depth of water increases. It starts increasing. It's slowly rising at about a half a foot every hour. Now you got to think, some pools are 4 feet deep, right? So if your pool was 4 feet deep, it would take you 8 hours to fill the pool. Okay? If you have 6 feet of water, it might take you 12 hours. Some pools, like the pool that I grew up with, had a 16 foot deep, so that would take a lot of hours to fill up that pool. All right, so right here, write a function d of t. So d of t represents depth of water. Depth of water depends on t. What does t mean? On hours. T hours. The depth of the water is going to depend, let me get this a little closer. The depth of the water depends on how many hours you're filling it. Okay, does that make sense? Let me focus this. So it tells you right here what that is. The depth of water increases at a rate of 5 feet per hour. That's what d of t is. So d of t is equal to 0.5 times your hours. Don't put h, put t, because t is representing hours. T represents hours. So t is hours. D is depth of water. Okay? T is hours. D is depth of water. D of t is depth of water depending on t hours. Now we're going to write a function v of d that gives the volume in cubic feet of the water in the pool when the depth of the water is d feet. So what is volume? Just so you know, volume is length times width times height. Okay, that's what volume is. So if I want v of d, I'm saying that the volume of the pool, of the water, depends on the depth. Or what else? What's another word for depth? How about the height of the water? The volume is depending on the height of the water. And that's going to depend on how many hours it's been going in. So V of D. So volume is going to depend on, first of all, your length, which is 18, your width, which is 9, and your height, which is not your, so we're not going to use H, we're going to use depth. Okay? D for height, or D for depth. Sorry. Instead of using H for height, I'm using D for depth. They're the same thing, depth and height. So this is our volume. You need 3 measurements, length, width, and height. Length, width, and depth. Is that one there? So what is 18 times 9? So V of D is whatever 18 times 9 is. Okay, oh, I found my calculator. Here it is. 18 times 9 is 162 times your height. So if we know what the depth is, then we can figure this out. Write an equation write an equation of the composite function V of D of T. So the volume basically depends on the depth of the water after T hours. That's what the whole V of D of T means. The volume, V, depends on the depth, D, which depends on the number of hours that you're filling your pool. So V of D of T. So what was D of T? D of T was right here, 0.5 T. D of T is 0.5 T. We're going to plug that in to this formula right here, D. So V of D of T is really V of 0.5 T. Because we are taking D of T, which is 0.5 T. We're taking all this and plugging it into D of T right here. So volume depends on 0.5 T. So in your volume formula, which was right here, or right here, 162D, it's 162 times D. What is D? D is being replaced with 0.5 T. So it was 162D. But we replaced D in this formula with D of T. It's V of D of T. So D of T is replacing D. So where the D was is now 0.5 T. I'm sorry. I'm not even on this page, right? Sorry, I have too many pens. All right. So it says V of D of T right here. Since D of T is right there, 0.5 T, that goes into this D right there, which is 162 times 0.5, which is 81 T. So V of D of T is equal to 81 T. So in other words, the volume of the water depends on the depth of the water after T hours. This is what it is reduced. So the range of the function D of T is 0 to 4 hours basically. D of T represents that the depth. So D is your this is your range, D of T. What is the greatest volume of water the pool can hold? So basically it's saying that the depth of the water can only go from 0 to 4 feet. So a lot of swimming pools in people's backyard don't go any higher than 4 feet deep. Okay, so the depth of the water can only go 0 to 4 feet. So the depth, the range of the function D of T, depth for time, based on this, what is the greatest volume of water the pool can hold? Or is it supposed to be 0 to 4 hours? Because, gosh, that's supposed to be T. The domain would be your hours. So the range is your depth. So your depth is 0 to 4. So the greatest volume, so the greatest D of T that you can have is 4. So plug in a 4 right there. Is 81 times 4. $324 is the greatest volume you can have, and that is in, what did it say it had to be in? Feet cubed. You guys want me? You guys come in.
We've been standing here like 15 minutes.
Oh, you guys come in. I'm just making a video. So you have 324 feet cubed is the greatest volume you can have. That's your range. So the range, the height, so your water is never going to go more than 4 feet. So if your water can only go 4 feet, the swimming pool can hold 324 cubic feet of water. Okay? I know it's a hard problem. You're not really going to have one like that on the test. I wanted you to try it. All right, 17 could be on your non-calculator. So the first thing they want you to do is graph this. Now you can punch it in your calculator if you want, but this is a quadratic that's 3 left, over 1, up 1, and over 2, up 4. Over 1, over 2, up 4. So here is your parabola. So graph f of x, that's what it looks like. Question B, what is the restricted domain of f of x? Well, right now your domain is negative infinity to infinity because it goes left to right. Your range currently is 0, bracket, to infinity. So if you're looking at domain and range, that's what you're looking at. The restricted domain is we need to take a portion of this off so that it passes the HLT. So right now it fails the HLT because there's repetition this way. So basically we're going to remove this section of it. We're removing that section of it. So the restricted domain so that it passes the HLT is going to be from -3 and greater. So you want to go from -3 to infinity. That's your restricted domain. Does that make sense? Here's your x. X is -3, so this is -3, 0. So you go from the x coordinate of your vertex, -3 to infinity. So now to find your inverse and to graph it on the same graph of 17, make sure it passes the VLT. All right, so first of all, I think we can go ahead and graph this. These ordered pairs, like this one's -3, 0, so you would need 0, -3. This ordered pair right here is -2, 1. So I need 1, -2. And this ordered pair right here is -1, 4. So we need 4, -1. So this is how you graph the inverse. So I've done that, graph. I've done that, check. So it's a graph, and then it says to find it. So your original one was y equals x plus 3 squared. Your inverse is switch. So finding the inverse, you switch x and y. Switch x and y. Okay, do you guys see that? This is the original, this is the inverse, and you have to solve for y. So to get rid of a square, you have to take the square root of both sides. You're supposed to put a plus and minus in. But because we took off half of our graph, we only need the positive part of that. So this is what you have, and then the last step is to subtract 3. So y equals square root of x minus 3, which means that the inverse is equal to square root of x minus 3. So that's the answer to C, finding the inverse. This red part up here is the graph of it, of the inverse. So you have this one and you have this one. And then what is the domain and range of the inverse? Well, this is your domain and range of the original one, but we changed this domain to this. So the range was, so this was your domain. Your range was the same thing, like 0 to infinity. That was of f of x right here. This is your restricted domain. The range was the same. So what we're going to do is switch these for our inverse. So that means your domain of the inverse should be the range of the original one. So it should be 0 to infinity. Does that make sense on our red graph that the domain is 0 to infinity? And the range of the inverse should be the domain of the original function, which is bracket -3 infinity. So it goes from -3 and up. And this should be a parenthesis, my fault. All infinities are parentheses, but the 0, -3 should be brackets. Perform operations and find the domain for each. Okay, so this first one is h minus g. So if you look at h and g, there's no restrictions on any domain. This is a line and this is a line, so you don't have to worry about any domain restriction. So h is 2x plus 3, put it in parentheses, minus g, and g is 3x plus 1. Distribute your negative. and add like terms. So it's just negative x. All real numbers for your domain. Oh, wait, this is not right. Sorry, wait, negative 3x. That's negative 1. Sorry, guys. This is negative 1. So this should be 2. So it should be negative x plus 2. My fault. Negative x plus 2. Now for the next one, it's a composition. So you're going to substitute j of x into the x of k. So the first thing we're going to do is find j of x. J of x is right here. Now, you just can't plug that in without realizing that there is a domain restriction on this. This is a square root function that goes like this. That's what it looks like. J's function looks like this. It has a domain. I'm going to write the domain right above it. The domain is all the x's greater than or equal to negative 2. Negative 2 makes it 0, so that's okay. And then all the other ones. But anything to the left of negative 2, you can graph this on your calculator if you want. And you'll see that it starts, the t-table starts at negative 2, negative 1, 0, 1. But anything to the left of negative 2 is an error sign. So this one has a domain. So when you punch this in, you have to be aware that there was a domain coming into this. So when you plug this into k, where's k? Here's k. K's got a restriction also. Here's k. K has, like, x cannot equal 0. So when you punch this in, it's going to be 1 over 2 times the square root of x plus 2 squared, which is 1 over 2. A square and a square root cancel. X plus 2, which is 1 over 2x plus 4. That's your answer. That's your answer. But coming in, we knew that x had to be greater than or equal to negative 2. So that domain still sticks. X has to be greater than negative 2. But we also had a restriction here because you had a fraction. X can't equal 0. So x has to be greater than, but it also, x cannot equal 0 as well because you had a double restriction here. Like x can't be 0. And in this one, x has to be greater than negative 2. So when you're going x is greater than negative 2 in a domain, you're going from negative 2 past here. But when you get to 0, that didn't work either because this cannot be 0 from the original. Let me think about this for a second. So x cannot be 0. Actually, I don't think you have to worry about this one. You don't even have to worry about this one. You have to worry about the final. So take your denominator, set it equal to 0, and tell me what makes that 0. X cannot equal negative 2. If x was negative 2, so don't worry about the 0 because you have to go to the final answer for this one. But you do have to worry about this original domain from the x because you plug this one in. So this domain is really what's sticking right now. But when you get to your final answer, you have this. Take your denominator, because this denominator is not allowed to be 0, and set it equal to 0. In other words, it cannot equal 0. Solve for x, and x cannot equal negative 2. So your original domain was x is greater than or equal to negative 2. But this one's saying, but x cannot equal negative 2. So take the equal part off, and your domain is x is greater than negative 2. Let's see what that looks like on our graph. So if I punch this thing right here in, 1, go to y equals. One divided by parenthesis 2 times the square root of x plus 2 squared. I go outside of this. So that's what that is. We need a parenthesis. 1 divided by, I think I need another parenthesis. All right. So here's what we have. And if you press graph, or second graph, oops, set my t-table up. There is an error now at negative 2. But originally I said x could be equal to negative 2. But because of this problem, negative 2 makes this final answer undefined. So negative 2 and anything behind it. Oh, now they're saying these work. Oh, these answers work for this final problem, but coming into this, they didn't work. Oh, don't worry so much about the domains. Just plug this in. Go to the original answer. X has to be greater than -2. Okay, so f of g of x. Let's plug in g of x. We're plugging this into f of x. So there's no restrictions going in, so you just have to worry about the final answer. So f of g of x is f of 3x plus 1. That is g of x. And you're plugging this into the f function, so you're taking this right here and plugging it into that x. So it's log base 2 of 3x plus 1. Let's graph that, since you're not good with logarithms. We're going to go alpha window 5. I'm putting in a 2, and I'm putting in a 3x plus 1. Graph. Oh, my graph's messed up. Zoom 6. You might not be able to see this, but the vertical asymptote, if you set this equal to 0, is -1/3. It's kind of hard to tell that in this graph. But if this is -1, there's an asymptote at -1/3. So if you look at the t-table, it looks like 0, 0 is a point on this. It looks like 1, 2 is a point on this. And that's what your graph would look like. So it looks like your domain is all the x's greater than -1/3. Because if you set this equal to 0, it tells you what your domain has to be. Sorry, you can't even see that. So on this one, punch this in the calculator. There is a vertical asymptote at -1/3, because if you set this equal to 0, logarithms, you cannot take the log of 0. So you set this equal to 0, it's -1/3, that's where your asymptote is. There was a point at 0, 0, and at 1, 0. Draw your graph, and it goes all the way up to this asymptote of -1/3. So just make sure your domain is x is greater than -1/3. Find the inverse of f of x. So f of x is equal to log base 2 of x, which means it's y equals log base 2 of x. So switch x and y. Switch x and y, so it's going to be, let me just do a little line here. So that's x equals log base 2 of y. Now to solve for y, we want to swoop. So this is 2 to the x equals y. So it's f inverse of x equals 2 to the x. This is the inverse. Now what does it mean if they ask you to plug a number in? So j of 14, first of all, let's find out what j of 14 is. J of 14 is, here's your j. So j of 14 is the square root of 14 plus 2. Because j was just x plus 2. J function right here is square root of x plus 2. I'm plugging 14 in for x. So what's 14 plus 2? 16. What's the square root of 16? 4. So j of 14 is equal to 4. So where it says find f of j of 14, we're finding f of 4. Because you're putting 4 in for j of 14. So f of 4, find your f function, is log base 2 of 4. If you don't know what that is, punch it in the calculator. The answer is 2. How do I punch that into the calculator? You do alpha window 5. Log base 2 of 4. Answer is 2. And the last problem. Write the equations of two functions g of x and f(x) so that f of g of x is equal to h of x. So here's the final composition. This is the final. What were they originally? So we're going to do g of x first, because that's on the inside, followed by f of x. So if you were plugging in a number to x, what would you do first? If I was doing it, I would add 2. So I want you to think of this as x plus 2. Now, I want you to pretend that this whole thing is x. Pretend now that this whole thing represents x. So when you're rewriting f of x, think of x plus 2. Anytime you see x plus 2, think x. So you're going to do x squared minus 3. That's your answers. Now, if you would have done it this way, this would also be correct. Some people, if they were plugging in the number for x, would have added 2 and squared it. So some of you may have just done the whole x plus 2 squared like this, which is fine. So what would f of x be? Now pretend this whole thing is x. So when you're looking at h of x, if you print that whole thing as x, it would be x minus 3, and that would also be correct. So either write it like this or write it like this. Both of these are correct.